So today we're going to talk about conversion problems. Conversion factors are a ratio of equivalent measurements. So it's like 1 foot equals 12 inches, 1 gallon equals 4 quarts, except for we're going to be using the metric system in the class and not the English imperial system. So 100 centimeters equals 1 meter, 1,000 uh, milligrams equals 1 gram, things like that. When a measurement is multiplied by a conversion factor, the numerical value is generally changed, but the actual size of the quantity measured remains the same. So if you think of it, the 12 inches equals 1 foot thing, if I've got 3 feet, I'm going to have 36 inches. So the number changed from 3 to 36, but my 3 feet is still 36 inches. I didn't actually change the size of it. And so that's what's important. Because with these conversion factors, we're going to be setting them up as a ratio of a fraction, and that fraction has to equal 1, because if you multiply by 1, then uh, you're not actually changing the amount. And so uh, like you're so to do that, like with the 3 feet, I would take 3 feet times 12 inches divided by 1 foot. The feet will cancel out because I've got feet in the numerator and denominator, and I'm left with 3 times 12 inches. Dimensional analysis, it's a fancy term for unit conversions. A dimension is just a unit. So anytime we have a measurement, we have a number and a unit. And these units or dimensions are based off of a standard. For instance, the standard kilogram is kept in a vault in, I believe, France. In fact, they just recently made a new one because the old one lost a few atoms essentially over time from sublimation, so straight from a solid to a gas without passing through the liquid state. And so they now have a more precise one. And technically, every single measuring device is based off of a standard that was all the way down the line, like a grandparent, great grandparent sort of thing, based off of those standard units. So that's how we know that 1 kilogram here is the same as a kilogram in France, is the same as a kilogram in China. Dimensional analysis provides you with an alternative approach to problem solving. So, converting between units, problems in which measurements with one unit are converted to equivalent measurement with another unit are easily solved with dimensional analysis. There are a few steps to follow. You're going to write the number you have over 1. Technically, you don't have to do that, but by putting it over 1, you just basically are setting things up to see uh, numerators next to each other and denominators next to each other. You're going to set up a fraction with the unit you want, final or intermediate, so maybe more than one step, over the unit you have. So, for instance, when I was talking about the uh, 3 feet times 12 inches divided by 1 foot, I put the unit I was looking for, 12 inches, on top, and the unit I had on bottom, 1 foot. Then you can cover up the base unit and place the equivalent of the prefix on the other half, so that's where the foot and 12 inches comes into play, or milli is 1,000, things like that. And you do that until all the conversions are completed as necessary. So basically, if it's a one-step problem, you've got a base unit. Either you're starting with a base unit or you're finishing with a base unit, or you're going to have a couple of steps where you have prefixes on both your starting amount and your finishing amount. So a couple of examples. If I want to convert 250 grams to kilograms, I'm going to take the 250 grams, I put it over 1 just so I can have my uh, fractions, my numerators together. All right, I have grams, so I put gram on the bottom. I'm looking for kilograms, so I put kilogram on top. Then I cover up my grams here, and I see a kilo is on top, so I need what a kilo equals on the bottom, 10 to the third, or 1,000. You could have written down 1,000. And then I just do the math. Everything in the numerator gets multiplied, everything in the denominator gets divided. 250 times 1 divided by 1 divided by 10 to the third, or 1,000. And that leaves me with 0.25 kilograms. So really, when I have the numbers in my numerator and denominator, we can cross those out and see what I've got left for my units. All right, convert 2.5 millicandela to microcandela. So remember, CD is its own unit. That's why most of our units are just one letter, and these are two, and they're same letters that can be used. The prefixes have like centi and deci, so it can be kind of confusing when we've got the candelas. But we're just talking about, uh, so we need to be sure that we keep our candelas together, the CD together, to make sure that we're not confused as we go through these. All right, so I have 2.5 millicandela. Since I have millicandela, I'm going to put MCD on the bottom, and CD is my base unit on top. And so I'm going to temporarily cover those. Let's see. And I see I have M on the bottom, and so I need what milli equals on top. And you can get that from your chart, 10 to the negative third. All right, and then over here I can do the same thing. I've got candela in my numerator, candela in my denominator, but I still have micro in my numerator because I'm not trying to stop at candela, I'm trying to get to microcandela, so I had to do a second step. Since I have micro in the numerator, I'm going to put 10 to the negative 6, which is what micro equals, in the denominator. Then we can cross out our units. Since I had MCD up top and MCD on the bottom, I cross them out. CD on top, CD on the bottom, cross them out. So now I'm just going to do the math. 2.5 times 10 to the negative third divided by 10 to the negative sixth. Remember, numerator you multiply, denominator you divide. So 2.5 times 10 to the negative third divided by 10 to the negative 6 gives me 2,500. And the unit that I was looking for, microcandela, is right there. Well, that's always fun. So your homework is to do these problems. Tomorrow you will have a worksheet to practice unit conversions. I'm trying to go a little slower with this unit just because I want to be able to answer your questions when I get there full time on Monday. So be sure to get your work done and email if you have questions.